Master of Architecture. MH4201. Sustainable Architecture, Historic and Community Perspective. Subject Concept Outline and Short Notes. Unit 5. Strategies for Sustainable Design. Strategies for sustainable design can vary depending on the project type, location, and specific goals, but some general principles and strategies include: site selection and analysis. Consider the environmental impact of the site selection and analyze the potential effects on the natural surroundings. Opt for locations that minimize environmental impact, promote biodiversity, and support ecosystems. Passive design. Incorporate passive design principles to reduce energy consumption and promote natural ventilation, daylighting, and thermal comfort. Passive design includes optimizing building orientation, optimizing glazing area, shading, insulation, and ventilation. Energy efficiency. Use energy-efficient systems and materials to reduce energy consumption and greenhouse gas emissions. This includes high-efficiency HVAC systems, LED lighting, and building automation systems that help optimize energy use. Water conservation. Reduce water consumption by installing low-flow fixtures, water-efficient appliances, and implementing a rainwater harvesting system. Greywater reuse can also be implemented to reduce water usage. Material selection. Choose sustainable and low-impact materials with minimal embodied energy and toxicity. This includes using recycled materials, renewable materials, and choosing materials that have a low carbon footprint. Waste reduction. Implement waste reduction strategies throughout the project, such as recycling and composting, to minimize waste generation and reduce the environmental impact of the project. Life cycle assessment. Consider the life cycle of materials and systems used in the building and assess their environmental impact from cradle to grave. This helps to identify areas for improvement and make informed decisions about material and system selection. Community engagement. Involve the community in the design process and consider their needs and desires. This helps to create a sense of ownership and ensures that the design reflects the community's values. Building performance monitoring. Monitor building performance and occupant behavior to ensure the building is operating at its maximum efficiency and identify areas for improvement. Building performance data can inform future design decisions and help achieve long-term sustainability goals. Examples of buildings that have implemented these strategies in India include Infosys Software Development Block in Bangalore, which uses passive design principles and a rainwater harvesting system, and the Suzlon One Earth Building in Pune, which uses sustainable materials and has a high-performance facade to reduce energy consumption. Strategies for sustainable design. Community participation in developing sustainable designs. Community participation is an important aspect of sustainable design, as it allows for a more inclusive and holistic approach to design that considers the needs, values, and aspirations of the people who will use and inhabit the built environment. Here are some strategies for community participation in developing sustainable designs. Community meetings and workshops. Hold public meetings and workshops to gather input from community members about their priorities and concerns. This can help identify key issues and opportunities and can also help build support and buy-in for sustainable design initiatives. Collaborative design charrettes. Bring together community members, designers, and other stakeholders for collaborative design workshops, or charrettes. This allows for a more participatory and inclusive design process and can help generate creative and innovative solutions that address the needs and aspirations of the community. Design Advisory Committees. Establish design advisory committees composed of community members and other stakeholders to provide ongoing input and guidance throughout the design process. Community outreach and education. Conduct community outreach and education programs to raise awareness and understanding about sustainable design principles, and to engage community members in the design process. Participatory budgeting. Incorporate participatory budgeting processes that allow community members to have a direct say in the allocation of resources and funding for sustainable design initiatives. Overall, community participation is critical to developing sustainable designs that are responsive to the needs, values, and aspirations of the people who will use and inhabit the built environment. By engaging and involving community members in the design process, designers can help ensure that sustainable design initiatives are more effective, equitable, and resilient over the long term. Strategies for sustainable design. Participatory approaches to learning and development. Participatory approaches to learning and development are strategies that involve individuals and communities in the design, planning, and implementation of sustainable development initiatives. These approaches recognize the importance of involving community members in the decision-making process to ensure that development projects meet their needs, values, and priorities. One of the key principles of participatory approaches to learning and development is that individuals and communities have valuable knowledge and experiences that can inform the design and implementation of sustainable development initiatives. By involving community members in the process, they can share their knowledge and provide valuable insights into the challenges and opportunities for sustainable development in their area. Participatory approaches to learning and development can take many forms, including community consultations, workshops, focus groups, and participatory research methods. These methods can be used to gather information, identify priorities, and co-create solutions with community members. Participatory approaches to learning and development can be applied to many areas of sustainable design, including sustainable building design, sustainable transportation, and sustainable urban planning. By involving community members in the process, sustainable design initiatives can better reflect the needs, values, and priorities of the people they are intended to serve. This can lead to greater community engagement, ownership, and sustainability of the initiatives over the long term. Strategies for sustainable design. Building and planning requirements. Building and planning requirements are essential strategies for sustainable design. These requirements are necessary to ensure that buildings are designed and constructed to meet sustainable goals and objectives. Some key building and planning requirements for sustainable design include building codes and standards. Building codes and standards set minimum requirements for the design and construction of buildings to ensure safety, health, and environmental protection. These codes and standards can be used to promote sustainable building practices, such as energy efficiency, water conservation, and the use of environmentally friendly materials. Zoning and land use regulations. Zoning and land use regulations can be used to promote sustainable development by encouraging compact, mixed-use development, protecting natural areas and resources, and reducing sprawl. These regulations can also be used to encourage the use of sustainable transportation modes, such as walking, cycling, and public transportation. Green building rating systems. Green building rating systems, such as LEED, Leadership in Energy and Environmental Design, and BREEAM, Building Research Establishment Environmental Assessment Method, provide a framework for designing and constructing sustainable buildings. These rating systems consider a range of factors, including energy efficiency, water conservation, indoor air quality, and the use of sustainable materials. Energy codes and standards. Energy codes and standards set minimum requirements for the energy efficiency of buildings. These codes and standards can be used to promote the use of renewable energy sources, such as solar and wind power, and the design and construction of energy-efficient buildings. Water conservation requirements. Water conservation requirements can be used to reduce water use in buildings and promote the use of water-efficient fixtures and appliances. These requirements can include restrictions on outdoor water use, requirements for water-efficient landscaping, and the use of water-efficient plumbing fixtures and appliances. Waste management requirements. Waste management requirements can be used to promote the reduction, reuse, and recycling of waste in buildings. These requirements can include the use of recycling facilities, requirements for waste reduction and reuse, and the use of sustainable materials. Overall, building and planning requirements are critical for achieving sustainable design goals. By establishing clear requirements and guidelines for sustainable building practices, these strategies can help to create more efficient, healthy, and environmentally friendly buildings and communities. Explain in detail green building evaluation systems. LEED, GREHA. Green building evaluation systems are frameworks used to evaluate the sustainability and environmental performance of buildings. LEED, Leadership in Energy and Environmental Design, and GREHA, Green Rating for Integrated Habitat Assessment, are two widely recognized green building certification systems. LEED, developed by the U.S. Green Building Council, USGBC, is one of the most widely used rating systems for green buildings globally. It provides a framework for design, construction, operation, and maintenance of green buildings, and offers certification for different levels of performance based on points earned in different categories such as sustainable site development, water efficiency, energy and atmosphere, materials and resources, indoor environmental quality, and innovation. Buildings can earn points in each category to achieve a certified, silver, gold, or platinum rating. GREHA, on the other hand, is an Indian green building rating system developed by the Energy and Resources Institute, TERI, and supported by the Ministry of New and Renewable Energy. The rating system evaluates the environmental performance of buildings across different climatic zones in India. It provides a 100-point rating system for assessing the environmental performance of buildings across different parameters, such as site selection and planning, sustainable architecture and design, energy efficiency, water conservation, waste management, and renewable energy adoption. The rating system also offers a 3-star, 4-star, and 5-star rating system. Both LEED and GREHA use similar criteria for sustainable design, such as energy efficiency, water conservation, and materials usage. However, GREHA specifically addresses the unique challenges faced in India, such as the hot and humid climate, the use of local materials, and the need for innovative solutions for water conservation and energy management. Green building evaluation systems such as LEED and GREHA are important tools for evaluating the environmental performance of buildings and promoting sustainable design practices. By encouraging the use of efficient technologies and promoting sustainable building practices, These systems can help reduce the environmental impact of buildings and improve the health and well-being of occupants. Legal instruments/incentives for sustainable buildings. There are several legal instruments and incentives that promote the development of sustainable buildings. Here are some examples. Building codes and standards. Governments can mandate building codes and standards that require new buildings to meet minimum energy and water efficiency standards, use sustainable building materials, and incorporate renewable energy sources. Tax incentives. Governments can offer tax incentives for developers and homeowners who invest in sustainable building practices. This includes tax credits for installing solar panels or other renewable energy sources, or tax breaks for using sustainable building materials. Certification programs. Certification programs, such as LEED and GREHA, provide recognition to buildings that meet certain sustainability standards. These programs often provide incentives for developers to incorporate sustainable design features into their buildings. Green building funds. Some governments and organizations offer funding programs for sustainable building projects. These funds can be used to cover the costs of implementing sustainable design features, such as energy-efficient HVAC systems, green roofs, or rainwater harvesting systems. Green leases. Green leases are agreements between landlords and tenants that require both parties to act in environmentally responsible ways. These leases can include provisions for reducing energy and water usage, using sustainable materials, and maintaining green spaces. Net metering. Net metering allows building owners to generate their own renewable energy and sell any excess energy back to the grid. Governments can incentivize net metering by offering rebates or other financial incentives. Density bonuses. Some cities offer density bonuses for developers who incorporate sustainable design features into their buildings. This allows developers to build taller or denser buildings than would otherwise be allowed, in exchange for meeting certain sustainability requirements. These legal instruments and incentives can help encourage the development of sustainable buildings and communities and can help to create a more sustainable built environment for the future. Legal instruments/incentives for sustainable buildings in India. In India, there are several legal instruments and incentives that promote sustainable buildings. Some of them are Energy Conservation Building Code, ECBC. ECBC is a code that sets minimum energy efficiency standards for buildings. It is mandatory for all new commercial buildings with a connected load of 100 kilowatts or more, or a contract demand of 120 kVA or more, to comply with ECBC. The code provides design guidelines and specifications for building envelopes, lighting, heating, ventilation, air conditioning, and electrical systems. Green Rating for Integrated Habitat Assessment, GREHA. GREHA is a national rating system for green buildings in India. It evaluates the environmental performance of buildings based on criteria such as site selection, energy efficiency, water conservation, waste management, and indoor air quality. The rating system is voluntary, and builders and developers can apply for certification based on the level of sustainability achieved. National Building Code, NBC. The NBC is a set of guidelines for building construction and design in India. It provides standards for the design, construction, and occupancy of buildings, including aspects such as fire and life safety, structural safety, and environmental sustainability. Incentives and subsidies. Several state governments in India offer incentives and subsidies for green buildings. For instance, the Delhi government provides a 5% rebate on property tax for buildings that comply with Griha norms. The Maharashtra government offers a 5 to 10% concession on property tax for buildings that have solar water heating systems or rainwater harvesting systems. The Smart Cities Mission. The Smart Cities Mission is an initiative of the Indian government to develop 100 smart cities across the country. The mission focuses on creating sustainable and livable cities by promoting the use of renewable energy, efficient transportation, and smart infrastructure. The mission also encourages the use of green building practices and technologies in new construction and renovation projects. Overall, these legal instruments and incentives aim to promote sustainable building practices and reduce the environmental impact of buildings in India. New concepts and trends in green buildings in India with examples and details. India has been making significant strides towards sustainable and green buildings in recent years. Here are some of the new concepts and trends in green buildings in India, along with examples. Net zero energy buildings, NZEBs. These are buildings that generate as much energy as they consume. One example of an NZEB in India is the Infosys campus in Bangalore, which generates 100% of its electricity from renewable sources and has a total energy savings of 43%. Passive solar design. This involves using the natural movement of the sun to maximize natural light and heat and minimize the need for artificial lighting and heating. The Indian Institute of Technology in Gandhinagar is an example of a building that uses passive solar design. Green roofs and walls. These are vegetative systems installed on the roofs and walls of buildings, which can reduce the urban heat island effect, improve air quality, and provide insulation. The CII Sarabji Godrej Green Business Center in Hyderabad has a green roof that helps to reduce the energy consumption of the building. Rainwater harvesting. This involves collecting and storing rainwater for later use, which can reduce the demand for municipal water and lower the strain on water resources. The Hiranandani estate in Mumbai has a rainwater harvesting system that collects and treats rainwater for use in landscaping and flushing toilets. Building integrated photovoltaics, BIPV. This involves integrating solar panels into the building's facade, roof, or other parts to generate electricity. The Suzlon One Earth building in Pune is an example of a building that uses BIPV to generate up to 25% of its energy needs. Waste management. This involves minimizing waste generated by the building and ensuring that any waste produced is disposed of in an environmentally responsible manner. The ITC Green Center in Gurgaon has a waste management system that ensures that over 99% of the waste generated by the building is recycled or reused. Smart building automation systems. These are systems that use sensors and controls to optimize the building's energy use and improve the indoor environment. The Wipro campus in Gurgaon has a smart building automation system that helps to reduce energy consumption and improve the comfort of the occupants. Overall, these new concepts and trends in green buildings demonstrate India's commitment to sustainable development and reducing the impact of buildings on the environment. New concepts and trends in green buildings in world with examples and details. There are several new concepts and trends in green buildings that are being implemented around the world. Here are some examples. Net zero energy buildings. These buildings produce as much energy as they consume. They use renewable energy sources like solar panels, wind turbines, and geothermal systems to generate electricity and reduce their carbon footprint. Examples include the Bullitt Center in Seattle and the CEB Tower in Grenoble, France. Biophilic design. This design approach focuses on connecting people with nature in the built environment. It incorporates natural elements like plants, water features, and natural light to improve indoor air quality, reduce stress, and enhance well-being. Examples include the Spheres in Seattle and the Edge in Amsterdam. Smart buildings. These buildings use advanced technology to optimize energy consumption, enhance occupant comfort, and improve building performance. They incorporate features like sensors, automation systems, and energy management software to monitor and control building systems. Examples include the Salesforce Tower in San Francisco and the Crystal in London. Passive house design. This design approach emphasizes energy efficiency and relies on airtight insulation and ventilation systems to reduce energy consumption. These buildings are designed to maintain a comfortable indoor temperature without relying on traditional heating and cooling systems. Examples include the House of Energy in Denmark and the Cornell Tech Residential Tower in New York City. Living buildings. These buildings are designed to be self-sufficient and regenerative, producing their own energy and managing their own water supply. They aim to have a positive impact on the environment and improve the health and well-being of occupants. Examples include the Brock Environmental Center in Virginia Beach and the Bullitt Center in Seattle. These are just a few examples of the new concepts and trends in green buildings that are being implemented around the world. Each of these approaches aims to reduce the environmental impact of buildings while enhancing occupant well-being and comfort. Brief an understanding of relation between sustainability and human history. The relationship between sustainability and human history is a complex and multifaceted one. Throughout history, humans have relied on the natural environment for resources such as food, water, and shelter. As human populations have grown and technology has advanced, the impact of human activities on the environment has become more significant, leading to a need for sustainable practices. Traditional societies around the world have developed ways of living in harmony with their natural environment, often incorporating sustainable practices into their daily lives. For example, many indigenous communities have relied on sustainable agricultural practices such as crop rotation and natural pest control to ensure that their crops continue to grow year after year without depleting the soil. Traditional architecture has also been designed to respond to the climate and environmental conditions of a region, incorporating features such as natural ventilation and rainwater harvesting. However, the Industrial Revolution marked a significant turning point in human history, with the emergence of mass production and a rapid increase in resource consumption. This led to environmental degradation, including air and water pollution, deforestation, and loss of biodiversity. As a result, sustainability has become a critical issue in the modern world, with a growing recognition of the need to find ways to live within the means of the planet's natural resources. Today, sustainability is increasingly being integrated into a wide range of fields, from architecture and urban planning to business and agriculture. Many countries have established policies and regulations to promote sustainable practices, such as reducing greenhouse gas emissions, promoting renewable energy, and conserving natural resources. The United Nations has also established the Sustainable Development Goals, a set of 17 goals aimed at ending poverty, protecting the planet, and promoting sustainable development. In summary, the relationship between sustainability and human history is a complex one, with traditional societies often incorporating sustainable practices into their daily lives, while modern society has had a significant impact on the environment. However, there is growing recognition of the need to promote sustainability in all aspects of human life, and many efforts are underway to achieve this goal. Explain knowledge about sustainable principles in built environments from the past and familiarity with their applications in contemporary situations. Throughout human history, sustainable principles have been applied in the built environment. Traditional and vernacular architecture in different regions of the world have developed over time based on the local climate, culture, and available materials, resulting in structures that are efficient, durable, and well-suited for their environment. For example, in hot and arid regions, buildings were often constructed with thick walls made of mud or stone to keep the interior cool and shaded courtyards to provide natural ventilation. In tropical regions, buildings were often elevated on stilts to protect against flooding and to allow for natural air circulation. In regions with heavy snowfall, buildings were constructed with steep roofs to prevent the accumulation of snow. These traditional principles of sustainability have become increasingly relevant in contemporary situations, as we face challenges such as climate change, resource depletion, and urbanization. Many architects and designers are now looking to the past for inspiration and incorporating traditional techniques and materials into modern buildings. Examples of contemporary sustainable buildings that incorporate traditional principles include the Sidwell Friends Middle School in Washington, D.C., which was designed with a green roof and rainwater harvesting system to reduce stormwater runoff and provide natural insulation, and the Bosco Verticale in Milan, Italy, which features a vertical forest of trees and plants that help to purify the air and reduce energy consumption. Overall, the knowledge and application of sustainable principles in built environments from the past are crucial in developing solutions for contemporary sustainability challenges. By incorporating traditional techniques and materials, we can create buildings that are not only environmentally friendly but also culturally relevant and socially responsible. Brief and understanding of sustainability in a holistic manner, incorporating past knowledge and current developments in the field. Sustainability is the concept of meeting the needs of the present generation without compromising the ability of future generations to meet their own needs. It is a holistic approach that considers the economic, social, and environmental aspects of human life. Incorporating past knowledge and current developments in the field is important in achieving sustainability in a holistic manner. Past knowledge from traditional and vernacular architecture can offer valuable insights into sustainable practices and principles, while current developments in technology and design can provide innovative solutions to sustainability challenges. Sustainability in a holistic manner requires a balance between economic development, social well-being, and environmental protection. This means considering the long-term impacts of human actions and decisions on the natural environment, as well as on social and economic systems. It also involves engaging in sustainable practices that promote the efficient use of resources, reduce waste, and mitigate the impacts of climate change. Overall, understanding sustainability in a holistic manner requires an interdisciplinary approach, combining knowledge and expertise from various fields such as architecture, engineering, urban planning, economics, social sciences, and environmental studies.